Hello and welcome to this 4IT Tech Elite session, the second of two delivered by Mike Robson, Head of Quality Assurance at TransUnion Information Group here in Leeds. Mike took us last week through TransUnion's 3-year journey from DevOps to DevSecOps to secure business agility. And today, Mike will give us a technical demonstration showing real-world dynamic interactive automated security tests, which can be embedded into a CI or CD builds. Mike Robson started his career in the 1980s world of electrical engineering, moving into software development and testing in the 90s and the 2000s, and for the past 16 years has helped numerous global brands deliver high quality and secure products. Mike's demonstration will last for 40 or 45 minutes, and then he'll take questions. So please put anything you want to ask as we go through the session into the chat box on your GoToWebinar toolbar, and we'll deal with as many questions as we can before we close the session. So I'll hand over the screen now and welcome Mike Robson.
Hi there, hi everybody, and I hope you can hear me. I'm hoping we're not going to have the technical difficulties that I faced at my end last time. So thank you, John, and your team for allowing me to finish off the presentation, and I hope everybody gets a little bit out of this today as we go through. So there's no real presentation per se in slides, but we are going to go through some of the things that we went over in training. So I'll go through an injection type attack. I will go through some of the PCI buffer overflow attack, and I'll also look at some secure configuration items that we may want to have a look at. Once we've done that, I will then move over to using OSWAP Zap, and I'll show you a trick that will stop actually Zap fully scanning your systems and looking for all the security vulnerabilities in there. And then finally finishing off with a run through of security tests, which are BDD, which are also in JUnit and also TestNG. See how you actually build those tests in and kick them in. And then we'll have a run through of that. And unfortunately, I didn't get the time to configure Jenkins build server, but you will be able to see the test running both with the UI switched on, so you can see what's being put into the system to test it. And I'll have also the UI switched off, so you can actually see how it would run in a build server to see what's actually going on. So the first thing that we do when we've done the training manually is we've obviously looked at what the OSWAP top 10 are. One of the common features of the top 10 is injection types. There are various different styles and various different methods, but one of the commonest ones is actually HTML injection. What this form represents is just a standard form, maybe a username or a password, and what you can do is you can put in information into the first name, and you can put code into the second name. Now, if we were coding this properly to make sure it would work, that we weren't susceptible to HTML injection attacks or even PHP or any type of code or source code attack, we've been validating that both the first name and the last name doesn't accept left and right chevrons. It doesn't accept certain types of source naming conventions. Therefore, you won't get something that is injected into the actual page itself, or what we call a document object model. We have other types, and I've got one here. I'm just going to copy and paste just to make it slightly different for everybody. Saves me having to write it, and we get a bit more time to see what's going on. What this is doing, we're actually injecting in a second form, and we're trying to inject into a picture. So if you look at this in the context of this was a username password to confirm a transaction, and you see a second username and password to reconfirm that transaction, what somebody's trying to do with this attack is actually try to steal your username and password and post it off to somewhere else where they can actually use it. So we can change the type of injection type that we want to do, and we can change the type of attack that we're doing. Code injection attacks are not limited to the actual form itself. You can see up here in the URL, it's actually pushing in a username. So if I wanted to change that index to master, and hopefully my cursor will work here. Yeah. What you can see is that injection now will look something slightly different, and you can change test injection to, hopefully that'll work again. test injection to tester, yeah, something like that, or gobbledygook, whatever you want. And then it'll also push that into the document object model. So what you're effectively doing is you're manipulating the form to put something in there, or you can manipulate the URL and the variables that are declared in the URL to manipulate what's actually happening. This also is common with cross-site request forgeries when you're manipulating various different bits of information. So that's one type of attack that could possibly happen. Another one, which is security misconfiguration, is when you're looking at robots.txt or metadata. So we'll take the robots.txt file. What you have tendency to do when you're building a website is you put something in to suppress robots. So robots are things like search engines, web crawlers, scrapers, all sorts of things going on in there. So you put something in to say, if I've got a good bot, disallow something or allow something depending what I do. There is a tendency though, when you look at websites and you go to the robots.txt file, which is publicly available information, people have declared an awful lot of information in there in regards to admin, passwords, etc., etc. One of the sites I tend to go to is Hack Yourself First. Hopefully, again, my keyboard's going to not play up to date. First, there we go. This is a fairly available website. It has a training admin behind it. It also has a few bits of information. If I was to look at doing some open source intelligence gathering, what I would effectively do is just basically go robots.txt file. I now have information in here that I would use if I wanted to try and exploit it, to try and find where things are at. And because I know where to look and how to do it, I can literally take everybody's username and password from the API straight away, because it's coming back in the JSON format, but it's not actually protected. It's not allowing us to do. So you can do path transversal through just the robots.txt file, finding where that information is. And again, it's nothing complex or hard to do. It's just knowing where to look, and once you've got the information, what to do. We then also, when we look at this and we look at the comparison sheet, we have controls that are OSWAP top 10, we have controls that are PCI DSS, and we also have controls which are SANS top 25. So I've shown you the OSWAP injection types, which could be HTML, PHP, JSON, could be JS, depends on what you want to push in. We'll also look at the same as a PCI DSS attack. And if I look at another type of attack that we can actually do, a buffer overflow, most of the testers out there will recognize this as boundary value analysis. You're putting in alphas, alphanumerics, and what you're trying to do is validate that the actual system will not allow you to put in only characters that are alpha, only characters that are numeric, and it will be set to a certain length. Because if it isn't, you could possibly get a buffer overflow or memory leak, or some issues or some error messages that would potentially give you the chance to do something and do something irreparable to that actual system. So we do things like that. Now, when you look at the system in regards to this particular website, and if you remember from, if you were on last week's session, this website is actually a honeypot, honeypot being a facility to capture how a hacker wants to hack into a system, therefore using it as threat intelligence to be able to build a strategy of how do we want to actually protect against certain types of attack. One of the tools that we could use, and it was mentioned, which is a fairly good tool, I quite like it, is OSWAP, and this is version 2.10 at the minute. And what I've done is I put in a morgleqa.co.uk in there. I'm going to run it just to show the web crawler for a reason. Hopefully this is going to work for me. Let's go. Should do it. It doesn't want to play a ball tonight. Thank you very much. Let's just try it one more time. And we just go hit return. Hopefully it'll go. There we go. We've got it to run. So what I'm doing here is I'm going through the site, and I'm actually crawling through the site at the minute to find out where the various elements are. And this is what we mean by robot suppression. We're sending a request, we're posting a request, and we're getting information back. And as you can see, it's going through the index page and all the way through. It is picking up particular alerts, and it's saying there are certain things that are not set. Here there is an absence of anti-cross-site request forgery tokens, and so on and so forth. So we get some information through. Yeah, while it's spidering through, yeah, it is looking at certain elements. Now, if you remember, what we've just looked at is the training site, training.imagoqa. That is actually another folder under a subdirectory within here. And what it's not doing is from OSWAP SAP, it's actually not picking up that subfolder in there whatsoever. It's just giving you imagoqa.co.uk. So there are other things within this site and subfolders that this will not pick up. So you're asking the question, why is that? Why doesn't it pick up? Well, when you look at the actual website, and I'll just close this. When you look at this actual website, there is a thing at the top which has been set, which is called robots meta tag, and it's set to no index, no follow. It's telling the search engines, don't follow me, don't register you or enumerate me into the actual index of the actual search engine itself. When you look at the actual network itself on this particular page, and I'll just hit return again, and we should get something to come up. Yeah, we're getting the source, but we're not getting anything to come up. So what we're doing here is we should have had a page come up here, and when you click on the page, you should be able to see that the actual website doesn't have no sniff, no follow. So I'm going to try this one just to prove a point. We'll take the network here. And there you go, we've got the information. So when we click on there, what is not set in here is no sniff, no follow. We're also giving away what type of web server it is. We're also giving away there's a PHP ID session available there as well to manipulate. So there's various different things that we can pick from here. So this is when we get on to how do we actually test that we are doing the right thing, that we are allowing certain pages of our application to be seen and enumerated in the search engine. And then we're also disallowing certain things not to be seen in search engines so that we keep ourselves secure, that we're not actually using insecure configurations, etc., etc. Well, what we can do is we can actually build a set of security tests that we can build in and kick into our actual automated paths that we use within CI/CD builds. So I'm going to look at, first off, I'm going to look at JUnit, and in here, what we've created is a set of libraries which we've imported. Nothing, again, that anybody probably doesn't recognize. There are extent reports, there is Selenium driver, there's also JUnit and Java IO as well. We set it up in this very similar way. So we've declared to set up extent reports. We have a before class, which is looking for the actual where to put the report, what to call the report for extent reports, and also which driver that we're actually picking up, we're actually going to run. We then have a stacked set of tests itself within the main class as methods. We have Chrome options set, so we can run this headless. We can run it with incognito mode, and we can size what we want. We can tell it where to go. And what we're actually doing is using XPath to find out, have we actually set a robot's meta tag to say, do we want to follow and therefore enumerate in the search engine or allow a web crawler to find us, or do we not? And we can pick out the attributes that we actually have in there. And then when we have the stack test again, we have one for a robots.txt file, and it's going and looking actually to find where the page source is at, try to read if there is a robots.txt file and actually pull that out. And then the last one, which also is quite a common thing you may see, is a sitemap.xml. Very good thing to do if you want people to find things on your website, but also what's a good thing to do can also be a bad thing, because people will actually use that, and particularly hackers, to actually trace where things are at on the site itself. So this is just a basic class that's written with methods in for tests. The second one, we'll just give you a couple of each one just to give you a flavor. Similar sort of thing. This time what we're looking for is particular things on the actual website. Following through, it's HTTP, HTTPS. So if we're want to run the site HTTPS, we want to make sure that it's not available on HTTP. So it's constantly going through a secure socket layer using something like TLS 1.2 or 1.3, depending what it is. And a lot of this code that's written here is to get around a bit of a proxy server that gives us various different error messages and stuff like that. So that's one way of doing it within JUnit. We can also use testng. So again, I'll pick on another couple of classes and we'll look at that. So before class, same declarations, looks very similar to JUnit. The difference is with the annotations, we can actually set thread pool size. So if you think about your CPU on your PC where you're running your tests, it may be 6 or 8 cores, which means you may be able to run 12 or 16 threads. You can actually run the tests as multi-threaded tests. You can also invoke these more than once, more than twice. So if you run 6 threads, you could probably run up to 100, 150 tests of the same ilk at the same time. So not only looking at it from a functional point of view, you can also look at it from a security point of view, you can look from it from a flood attack point of view, and you can also look at some UI performance point of views as well when you're running the actual test. In this example, the test data isn't sitting within the test itself, it's actually being pulled in through an Excel spreadsheet. So when you've seen my screen before, we actually have a SQL database and it has information in there, including the injection types. So I'm going to show you with the BDD framework that you can actually pull your information from a database rather than just an Excel spreadsheet. And there's a reason for that, but I'll get onto that slightly later on. When you're working through here, you can see that we've set a simple counter saying we're going to do an SQL injection attack. Yeah, we've pulled from the spreadsheet, so we're pulling the information that we want to pull, and we're using that to inject into the actual system itself. And then we're producing a report to say, does it allow injection to happen or does it not allow injection to happen? Again, we've stacked the tests up. So we're not just running SQL injection, we're also running HTML injection, and we're also running cross-site scripting, and we're also running PHP as well. And we've got a nice little attack in with PHP called add_eval. And if you're not aware what add_eval does, it allows you to declare public function. And if you get the wrong public function exposed, you could use some command like show source, which is part of the PHP toolset, and it will show you that the full server-side source code. And if you've declared your database username and password in plain text, it will expose that to the internet. So quite a dangerous thing when you look at it. Finally, looking at the 3 variations on a theme, we have BDD, and it's a cut-down version of JBehave or Serenity, depending on which of the flavors you like to look at. And what we have is on the left-hand side here, we have our feature files. So again, if we look at web crawler suppression, it's fairly straightforward. We've kept them very simple. We're not writing them with scenario outline. We're just purely writing them with scenario and keeping it simple. We then have the glue code. So if you look at this from a static point of view, the glue code is looking for the given when then, the action words. It's looking for what's actually in against the feature file, the words themselves. And we've got this setting up the Chrome driver. We've got this going through and opening the URL, looking for HTTP and HTTPS. We then also go through and checking index files, finding out what's available in there. We're looking for robots meta tags, so on and so forth, and then we close out the test. And we can do this doing brute force a dictionary tag. So again, keeping it very simple, not using scenario outline, and just purely looking from this is where we need to run. When I look at the glue code for brute force, this time instead of using an Excel spreadsheet, we are connecting to a database, in this case MySQL. I haven't set it secure because there's nothing in there that's PII. There's nothing in there that that would cause a problem if it was audited. But this is just purely on a virtual machine on a private network, and it's not going to do anything other than just do a demonstration. We're going to run through the tests. We're going to push in the information into the various components that we want to do within the method, And we're going to do this in various different ways all the way through the actual step definitions. And finally, fairly straightforward, we have a test runner which we use with BDD. So what I'm going to do first off is I'm going to close the BDD. I'm going to come back to JUnit, and I'm actually going to run this, and you'll see some tests running. Yeah, and hopefully running at a speed that it's quite all right with you. So here goes the first test, and it's picking up some information. Here goes the second test. I'll pull the console up so you can see it. So it's done HTTP, HTTPS. It's looked for hard-code emails on the main page. You may ask why hard-code emails. Well, it can give away a combination of your domain and how your emails are constructed, which could be used as a flood attack, or it could be used to do a denial of service attack and bring your systems down. Sometimes that's how it actually works. We've gone through, and I'm just waiting for what it's the robots.txt file. I couldn't find one. It's looking for a sitemap, can't find one, and it was reporting back what's actually happening. Now it's going to try and do a password a guess, and it's going to try and do it for 3 times, and if it doesn't get in, it's going to see if it does the system log out, which it should do. So we're going for number 4, see what comes next. There you go, didn't work, it's still allowing you to do stuff. It's now going to go for a brute force attack. Again, quite simple to write within JUnit or testng or whatever, NUnit, C#, etc., etc. And if we put some random think time into the actual the code base itself, we can, sort of confuse the detection systems and sometimes get past them to carry on, keep doing this. Obviously, we need to be careful. We also need to spoof the IP address, and there you go, we broke in with the username and password. Now we know what the username is. We're going to do a dictionary attack. So we're just going to put the same user in, and we're going to run through a set of dictionary passwords to see where we actually get and see if we can break in. And it's going to go through a bit, and it's going to keep going until we find it. And when you see it finally eventually get in, you'll see the actual banking system come up. There you go, we've broken in again. This time what we're going to do is we're going to do injection into the form. This is an account application. This is a SQL string that's taken from Metasploit. So again, we're using strings that are used with other security tools. We're putting that in, and we're going right the way through the form itself. The idea of this is to demonstrate if you're not validating your form, this is what you're open to. And it may not necessarily mean that you get an error. It may not necessarily mean there'll be an issue. But that data is now gone into the database. Yeah, what can that do from another system or another type of attack? So this time we're going to do some iframe injection. If you're not aware of iframes, an iframe allows you to put another part of the source code into play, and you can do anything within that source code. So it's quite a dangerous thing to do if we're not careful with it as we're going through the systems. As you can see, I've probably slowed this down. You can run it a little bit faster than this, but I'd like you to see what's actually happening as we're doing it. This one here is a cross-site scripting, again taken from Metasploit, and again it's running through, and it's going to allow us to inject the code base into here. And what this should be doing is, if we had programmed this correctly, it should be restricting the length of the fields. It should also be saying, I see chevrons in the actual information, therefore I'm going to reject it, or I'm going to report it as an issue here, and therefore it doesn't get to the database. This is another type of injection attack, and this is PHP, and this one is the dangerous one, @eval. So if you change that @eval, use a name, and then followed by source, show source, you would actually be able to see the PHP source code that sits behind any PHP website. Yeah, very dangerous thing to do, something we shouldn't declare. You can also use @eval in JS, JavaScript, and again, it's a dangerous thing to use because you can use JavaScript functions through the browser to get into systems. If you've heard of Hack Yourself First, that's how they actually invite you to do it. You go through a function on the browser itself and just use JS to get in. This is again going to go through the form. It's telling you what type of attack it is, and it's doing SQL injection, and it's accepting it. So again, no validation. So I wrote this, so I personally say don't get me to write you a banking site because it'll be insecure, and don't use investment bank because it's not a real site, it's just a training site. Again, we're doing some cross-site scripting, jQuery JS injection, and away it's taking it again, no problem whatsoever. And this time we're doing some PHP, and away through it's going again, and it's taking that information. And it's allowing us to do the form. And it's found an API as well, because doing path transversal, it doesn't found an admin site. It's found a PHP, so that we can attack that as well and try and get it in the database direct. It's found a content management system, so we can attack that and get in direct. Doesn't look like it's got WordPress because it has another type of CMS on here. It's not got any assets folders, not got any libraries, so we're okay. Not got anything local. No files. And that is it. That is that run complete. Now, what you can see in here, you've got JUnit and says all the tests are run completed. Everything is all right. We're not using this to report results. What we're using this for is to make sure our tests actually run and don't fall over. So the glue that we've put together to be the test and the complexity we want, it actually works. What we're using is extent reports. What we're using that for is actually as a nice clear report to say what was actually happening. So we've set this up and we said from a PCI DSS 6.5, yeah, we want it to be secure communication. So we have got secure communication, but in this particular example, as developers, we've been lazy and we should have switched off HTTP so the site wouldn't be available at that particular juncture. And if we look at another one, client login, you can see the number of attempts. So we're using OSWAP A2, which is also PCI 6.5.10. We've gone all the way through, and you can see the credentials that we've used to actually break in to the actual system after a number of attempts. And again, you can see that we're doing it again. We're going to use a password for a dictionary attack, and it'll come out of that. And then we tried finally to do a path transversal attempt with a credential, and it didn't like that either. So we've got enough information in there to actually give us a good handle on what the security posture is of this particular site or this application. So what I'm going to do now is I'm just going to run one of the test-ng tests. This one, I'll just pick eeny, meeny, miny, moe. We'll have a go at that one. We'll just pick number 5. And I'm just going to run this, and we're just going to see this in action as well. So I'll just bring the console back up. This is now running with completely headless and just gone straight through. That didn't take too long, so let's do something a little bit longer. Again, we'll just pick something. And we're running again. So this has got the head switched on. It's going to go through the same thing again, 3 to 4 times. Does the actual system lock the account or not? And you can see this time I've got it running a little bit faster. It doesn't lock the system. Again, this is brute force attack, and it's going to go all the way through. And it's just going to keep going until it can get itself into the system. There's no random think time built into this, but you could do that. And you can see it's going through here in the console. It looks like it's not doing anything, but you can see it's picked up. It's done a brute force attack. It's got the password and username. And there we go. We've done dictionary attack and confirmed the password. Yeah, and we've done the thing, and there you go. So this gives you 2 variations on a theme. If you were using NUnit, which is the Microsoft's variant of JUnit, you could do exactly the same within there. You can set your suite of tests. You can build a package, put that package into your build server and actually run it. Now, our new favorite actual security testing tool is actually BDD framework. And again, the reason why we're using feature files if we've got non-technical people in our team, they can understand, if we train them manually, what do we need to write as a test, and we can put it in here. One of the things that we want to try and avoid is using scenario outline. We call it the Mephistopheles character from German folklore, the devil itself. And the reason for it is we may inadvertently put in passwords, usernames, PII data that we think's not a real person, but could be a real person. And therefore, we're going to get what we call PII leakage into our source repositories, our build servers, and leak into places where we don't want it to be. So what we try and encourage is move away from scenario outline and actually use just scenario, so you're not putting username and password in there, but within your glue code, within your step definitions, you actually are going to put in the information from the database. So I'll show you the database itself. It's just a simple one, nothing complex. So for brute force, usernames, passwords, and you just pull from there. For dictionary tag, just purely passwords, you can just pull from that. From injection types, you can build yourself a little bit of a library, and you can set what kind of strings that you want to put in there, and you can put various different things in and then just pull from here as well. And then path transversally, it's quite an easy one, just telling it where to go on the actual paths of the root directory where the web application is actually at. So we'll run not brute force, we'll try static run here, and we'll run this, and we'll see what we get. So we've already filled the test. I can see it in the console, and we've filled another one. And we're going to fill another one, I suspect. So please don't invest your money in Investo Bank. It's not very secure. There we go, going for sitemap. There you go. So what we've done is we've used assertion this time as part of the glue code. We've had a feature hard-coded email addresses, and it's telling us it's failed. Yeah, there is a problem here because ultimately there are hard-coded email addresses. It's gone through here and it's looked at the hardcoded.com email address. Then there's one there. It's gone through and passed this test. This test, it's failed. Yeah, the banking site should be presented with HTTP. Yeah, using HTTP. Yeah, it's coming up with HTTPS, and it also gives us a code as well. And we're going through various different checks and it's failing. So when we look at this from a reporting point of view, yeah, we need to do some work on that actual banking application to make it secure. So I hope that this gives you some ideas, maybe some thoughts that you can use functional test tools that are for automation or for unit testing or whatever, and you can adapt them and modify them quite easily and quite simply if you can understand what type of thing that you want to do in regards to the attack type or security posture you want to give your web applications. Also, when we showed you OSWAP SAP, it's giving you an indication that you can actually trick SAP not even see half of your site or half of your directories. Therefore, your security posture may be in question. It is a good thing, as we mentioned from the previous session, that you want your information to be presented in a report. You want to be sharing it with your third-party pen testers or your internal pen testers, because you want to do this in a layered approach as part of DevSecOps, so that when you go to the production of your applications and services, it is in a very good secure position. Because I look at it as I previously mentioned, if I can help protect one organization or many organizations, not only are we helping those groups of companies, we're helping also groups of people, individuals, and you're also helping yourself as well to try and protect that data. And the ultimate goal is beat cybercrime, because it's not good for anybody, and we want to try and do that as the best thing that we can do. So that is hopefully the presentation. I'm going to hand back to John for questions and answers. I'll log off my screen. Over to you, John.
Thank you, Mike. Thank you very much for that. Yes, we do have one or two questions now. Bear with me a moment. Yes. Yes. How long will it take, asks one questioner, to run tests for a whole website covering all aspects, and how many cycles would you envisage to fix bugs found? typically that is, and how long to prepare the scripts before test execution?
It would depend on understanding how big the site is, how many requirements there are, what inputs, what outputs. It's not something I could answer off the top of my head, because I don't believe there is an answer, because every site, every application is different. You would have to estimate what you're doing. I'd probably say that, based on your requirements, depending on how you estimate, you may be using story points, you may be using function point analysis, will give you some sort of indication. But ultimately, it's down to how much have you got to test, and it could be down to you only have a budget of so much, and when the budget runs out, you have to stop. As for how much can you test, theoretically you can test as long as you want if you've got pockets of money to carry on and doing it. But there comes a point where you've got to say, how secure do you want to be? So I can't really answer the question definitively. All I can say is, what are your requirements for security posture? How you built your epics and stories? What do you want to test? And can you build tests in a way that are smart enough to do a number of different things in a way that you're only having to maintain them through changing data rather than having to change the code itself?
And on the subject of writing the tests, what skills do you need to be able to write security tests, Mike?
Well, the first one is, if you've come from a programming background, or if you've come from SDET or functional automated tester in my day, that gives you a good sort of starting point, because you can write code. Yeah, what style of code you write it in is pretty irrelevant. If you look at Kali Linux, a lot of the actual security tools are written in Python. So you could use Python as the glue code. You could use feature files as the actual front end and put it together so you have a cross-skilled team. The second part you're going to need is the understanding of what and how you're trying to test. So you're looking at some sort of training course. You're looking at what is important in that training course. So I've been on quite a few myself. A lot of them give you the theory, but there's no actual practice. Some of them give you the actual practice as well as the theory, sort of ethical hacking from the Council of Ethical Hackers. And then there are some training sites where, like Plural site, where you will get access to particular information, and then you will have some exercises to go against Hack Yourself First website. And then there's also things like Immersive Labs and Hack the Box. So I've experienced it when we did the training itself. From a TU perspective, what we found works best wasn't going to an online system that says, here is the theory, here are the practical tests, because there's a bit of a disjoint, because then you've got to try and work out, how do you put that into your CI/CD builds? What should I really be testing for and getting the value add, versus what is just an exercise of doing something because it says to do it in the actual book itself. What we found was, it's probably better finding something that is tutor-led, and actually being able to ask the tutor, how do you go and do certain things? Because they'll sort of say, if you want to be OSWAP top 10 or use those controls, this is what you need to do, or PCI DSS, etc., etc. They'll get you to walk through the exercises. But then you also have an opportunity to go back to somebody once you start doing it for real in your organization, to say, right, okay, how do you do this? Have you had this problem? How do you solve this? How do you, X and Y? So we found that works better doing tutor-led online, and going through the exercises, and then people coming back to the tutors and actually asking the questions, how do we do the next stage, and where do we go then? And when they go off and do that, and they may run that for a month or two, and then they come back and ask a little bit more, and then do another 2 or 3 months. But all the time, it's improving the posture. All the time, it's improving the skill set, because it's a good skill set to have, because it's not too difficult to write certain types of tests that are quite similar to functional tests, and then there are ones that are absolutely specific to security and nothing else, and it's just weeding out which ones you need to do and which ones you don't need to do. And then if you're not 100% sure and you don't think you've got really good coverage, you've always got your pen testers to come in and give you an extra bit of hand, so you've got that layered approach. So that would be my sort of take on how would I do it based on experience. It's got to be tutor-led, somewhere where I can go back to ask the questions when I get into positions of trying to deliver, but not quite sure what I'm delivering.
And having done all of that and used the tests, what should you do if you find minor security flaws?
That's a very good question. Yeah. So you find a whole load of security flaws in your system, and you've got your criticals, you've got your highs, you've got your mediums, and you've got your lows, the very minor stuff. It's all down to your risk appetite. You know, are you wanting to go with you know, everything's perfect in a perfect world? Don't think so. I don't think there's any organization would do that. But there is a minimum sort of level you're going to say, we'll not go live with critical issues because that's going to really cause us problems. Got no appetite to go with high issues, so I'm going to address all the criticals and highs. I'm at the point where mediums are still there, so I'm going to address the mediums, but there are some low ones where we just don't need to touch because the likelihood of it actually happening and the probability of it happening and the impact is so small, it's not worth the effort to actually fix. So it is the risk appetite of the organization. How far do you want to go? How secure do you need to be versus do you need to do everything? And again, we use the same principles for delivering software. You know, do we do everything in a perfect world, or do we deliver a minimum viable product and take a little bit of risk? You know, that's, you know, every organization is different, but risk appetite is the simple answer to it. If you've got a low risk appetite, you fix everything. If you've got a high risk appetite, you let quite a few things go, and it depends on what really matters to the organization.
Okay, we've got a question about tools that we'll come to, but in the meantime, it seems, says one of our attendees, that the modern day programmer needs to understand cybersecurity and be an ethical hacker. Is this a fair statement? Or can a programmer be ignorant of cybersecurity and rely on the cyber or the information security of the company to resolve security programming issues?
Yeah, there's a couple of difficulties in that question, so I'd probably take the first part and say it's good practice from an engineering point of view, where it doesn't matter who you are, to actually be able to do cyber security and develop the product and make sure it's secure. Because if you've got that understanding, you've got that training, and you have to be PCI DSS compliant, you have to do it. There's no sort of way of getting out of it, but also you're building up a skill set and giving yourself a positive. On the other hand, there are organizations that will rely on third-party pen testers as a catch-all, and there have been cases out there where up to 150 million individuals have had their data leaked because the pen testing was the catch-all, and unfortunately didn't catch-all. So again, you've got to sort of consider that what is the risk to the company. So if you're heavy into data and you're heavy regulated, yeah, your option is you make sure you train all your developers and your engineers and you follow that culture of being secure. If on the other hand, you're producing something that is, you know, a nut and bolt that's got no real criminal value, has no real data to it, then you can be a lot more looser with your security parameters in that respect. But it really depends, because if you have a data breach or you're hacked and you unfortunately get on the list of shame, how long will it take your organization to actually recover from that? Can it ever recover from that is the other question as well.
So there's a couple of questions around tools. How do you determine which tech stack and tools to use in regards to automating tests?
Again, that's a really good question. I've had this would be the second time this week, and I'm probably a controversial guy because I'm tech stack agnostic in regards to, for argument's sake, if I had a C# web application that's written out there, I'm not adverse to running JUnit against a C# application. It does what it needs to do. Everything works. You get the results that you need. If you look at some of the Linux distributions, which are specifically security focused, the tools that are on there, a lot of them are Python based. So if you're running, say, a certificate scan, against the website to look and see if the SSL certificate's in the right place, you will probably find you're running Python maybe against something that is the tech stack is Microsoft. So it really sort of gets down to the point of, do you have really good, solid people and engineers who write code? And if they do and they don't need assistance, then you can be tech stack agnostic to tools and also how you deliver your products. On the other hand, if you need some assistance, it's probably a good idea, say if you're in the Microsoft's world, to have the tools from the Microsoft world. So in this case for BDD, SpecFlow, because it's C#, wrapped around the feature file, so therefore it'll go with the C# stack. If you're in the Java world, probably JUnit TestNG, or as I've just shown here, JBehave for BDD. But it really is down to the organization and where the strengths and the weaknesses lie with the teams themselves. But yeah, I'm not adverse to running C# against Java, Java against C#. Whatever gets the result to make sure it's secure, yeah, that's the best process. So it's not uncommon these days for people to use JMeter for performance testing against Microsoft's technology stack. If you can think like that and work like that, it's probably a better way, because you can evaluate better tools and get the best tools to do the right job.
And which tool vendors would you recommend? And are there any open source tools that you could suggest?
Yeah, so open source tools, OSWAPS app is a fairly good tool. I quite like it. There is Burp Suite. If you're into your Linux and like VMware, or VirtualBox, I would recommend trying Kali. It's quite common. I'd also recommend trying Parrot OS. And there's also one called Backbox. There's around about 2,500 tools on there. You can, get yourself a good, set of skills. What I wouldn't recommend though is set up or just go and throw it at any website, because there is a thing called the Computer Misuse Act, and you have to have permission to do that security testing against a particular element. So be careful, but I would recommend getting something like those tools. I would also recommend OSWAP's WebGoat, which is an insecure web application, or try and look at something like Hack the Box and see if you can actually get in and hack into it, get yourself an account. And then there's loads of things in there that are deliberately set up so you can actually hone your skills and become better at it. But it's like anything, you're going to start off at a low position, you're going to learn to crawl, you're going to learn to walk, then you're going to learn to run, then you're going to learn to sprint. It's what effort you want to put into it gets you the results at the end of it. So it's a little bit of a journey, but I thoroughly recommend it. It's worth everything to make yourself secure, make organizations secure, and defeat cybercrime.
Well, that's all the questions we have, Mike. So thank you very much indeed. You've given us a fascinating technical demonstration, and I have to say something of an eye-opener. We'll share the recording of this session in the next day or so. And when you close this session, and then again in an hour's time, you'll receive an invitation to complete a very quick survey. Tell us how you found it today and how we can make these sessions even better. We would really value your input to that. But in the meantime, I hope you've enjoyed this session. Thank you for being here, and thank you, Mike Robson, and thank you, TransUnion, and goodbye.